Hi, my name is Maggie Mulligan and I'm a freshman here and I'm a chemistry major on the biochem track. Some things about me: I'm from Wilmington, North Carolina. I have two little sisters. I love the beach and spending time in the ocean. I'm also a marine science minor in addition to the chem major. So I want to be a learning assistant because I've really learned a lot from my learning assistants in 101 and 102, and they helped me feel like I could succeed in this really challenging course, and I would love to make other students feel that way. I was really intimidated coming into my chemistry courses here, and having people the same age and almost the same experience level as me and hearing about how they succeeded in the course was very helpful and valuable for me, and I'd love to be able to help other people as well. I would really love the opportunity to help students develop better learning and study strategies, and I would do this by sharing what works for me and maybe what works for my peers. And what works for me is doing a lot of practice problems and really working to understand why you solve a problem a specific way rather than just memorizing the steps. I feel that really helps me, and I would love to pass that along to other students. The problem I'm going to go through today is a method of initial rates problem. So it says determine the rate law of the following reaction given the table of initial rates. And the reaction is A plus B plus C to products, and you can see we have 4 trials given. So what we'll start with is just writing out what we know so far. So we have rate equals rate constant times concentration of A to the X, B to the Y, and C to the Z. So we want to choose trials where all the concentrations are the same except for A. So that would be trials 1 and 3. So we do rate 1 and rate 3, and then we'll plug in those concentrations from the table. So it's 0.005 for A, 0.0025 for B, and 0.0010 for C. So that's for trial 1. So then we'll do trial 3. So A is 0.010, B is 0.0025, and C is 0.0010. And then we'll also plug in those rates as well. So it's 2.0 times 10 to the negative 4th, and also 2.0 times 10 to the negative 4th for trial 3 as well. So those concentrations are going to cancel, as well as the rate constant will cancel. So the rate constants divided by, or the rates divided by each other equals 1. So I'm just rewriting here what we have left. 0.005 to the x over 0.01 to the x equals 1. So that simplifies to 1/2 to the x equals 1. And anything to the 0 power is 1, so x equals 0. So that means our reaction order with respect to A is 0. And this means we can disregard A from the rate expression because anything to the 0 is 1, so it's not going to change the value. And we're just going to go ahead and repeat these steps for reactants B and reactant C. So the final thing to do is solve for K, so we can use any trial. I'm just going to use trial 1, and we plug in the values we found. So K times 0.005 to the 0 times 0.0025 squared times 0.001 to the first equals 2.0 times 10 to the negative 4th. So when you solve that out, you get K equals 32,000, and the next thing to consider is units. So each concentration is molar, and the rate is molar per second. So K has to be 1 over molar squared times seconds in order for the units to cancel out to get the correct unit. So when you plug everything in, that's what you get as your answer.